Test, test. What's up, you math nerds? Hope you're having a fabulous afternoon, evening, or morning wherever you're tuning in. My name's Miguel, also known as the Vegan Math Guy, and this is Tuesday's Integration Bee. Let me know if you can hear me. I want to make sure that my mic is working. Let me know in the chat if you can actually hear my voice. The quality is a little weird. I don't like that light. It looks way too bright. Give me 1 second, guys. Okay, this might fix things just a little bit. Oh, if not, I can move my camera. But let me know if you don't like that that angle. But anyway, we're going to do a few integral problems, and feel free to follow along. Again, if you can hear me, let me know in the chat. I'm going to move some stuff around here. I think that's a little better. Yeah, see, that video quality is a lot better. So anyway, we're just going to start off with, I like to say, a basic integral. Integration B on Tuesdays are typically going to be more difficult integrals that we can kind of work on together. So let me go ahead and write the first one. And again, if you have any thoughts on this integral, on the methods that we can use, go ahead and let me know in the chat. I would love to hear from you, and I would love to hear on how we can solve this. Okay, so looking at this first integral, I would love to hear what method we should use. Is it U substitution? Is it power rule? Is it partial fraction decomposition? Is it something else? What do you think? Just seeing that the degree on the top is one less than the bottom, I'm going to go ahead and try to use U substitution. And let's see what happens. Okay, so someone said U sub, someone said derivative. Joy, what's going on? Let's go ahead and try U sub. And this is actually one of these methods that I like to review with a lot of you guys, because you're going to see that we're going to have to do a little bit of prep work before we even do any U substitution. Shark Boy, good luck on that math test. Now that I found my U, because it is going to be U at some point, we're going to go ahead and take the du. That's going to be 2x plus 4 dx. Now, just to prep us, check this out. I'm going to divide the 2x plus 4 on the other side, and now I have my du. But look at what's going to happen. I'm going to have 2x plus 3 over our u times du over 2x plus 4. Does anyone see an issue with that right now? Hope your spring break is doing well. Optimization, that will probably be on Thursday, but we do some math survival skills. Tuesdays are just integrals. Okay, so Tuesdays are integration Bs. So again, we did U substitution. If you notice, we have 2x plus 4 on the bottom. Doesn't quite cancel out with the 2x plus 3 on top. So U substitution was going to be correct, but we have to do a little bit of prep work, okay? Because on the top, I want to have a 2x plus 4. Look what I'm going to do. Check out what I'm going to do in the numerator. I'm going to go ahead and add a 4, and I'm going to subtract the 4 at the same time. The reason why I'm doing this is because 4 minus 4 is 0, so we still have the same integral. And now I'm going to rewrite this. So I have 2x plus the 4, and then I'm going to combine the 3 and the minus 4 in a second, but I just kind of want to rewrite this. This whole thing is still over u times du over 2x plus 4. And now let's go ahead and rewrite this. 2x plus 4 minus 1 over u times du over 2x plus 4. There's still some issues there. Valerie, good luck on that test tomorrow. All about e's. I do have an integral involving e's that we can work on after this. All right, but check this out, guys. I'm going to separate this. On the top, I still have 2x plus 4 minus 1. So we're going to have to separate this into two different integrals here. So we have the 2x plus 4 over u minus the 1 over u. And then the whole thing is still being multiplied by 2x plus 4. So you see that we're going to run into some issues. Let me go ahead and create some space on the blackboard here. and we're going to continue to solve this. We're going to have two different integrals. One's going to be really easy to solve. The other one's going to take some time to complete. Okay. Now that we have the 2x plus 4 over u times, I can go ahead and write the du over 2x plus 4. And then I still have that other integral, 1 over u times du over 2x plus 4. That first integral, that was really easy. That 2x plus 4 cancels out. So we have 1 over u du. We'll fix that in a second. And now for this other one, we can cancel out that 2x plus 4. Let me rewrite this. Bear with me. I'm going to rewrite that u value that we had. And it's going to be x squared plus 4x plus 20. And then I still have, I'm going to rewrite the du over 2x plus 4 as my dx. You're going to see why I'm doing that. So that first integral, let me go ahead and just circle it in green. That's just going to become natural log of u, which is the natural log of x squared plus 4x plus 20. And now we have this problem still. We have natural log of x squared plus 4x plus 20 minus integral of 1 over x squared plus 4x plus 20 dx. So let's go ahead and, again, create some space in the blackboard. As I mentioned, Tuesdays are always more difficult integrals than usual. Thursdays will probably be more basic stuff. We can do optimization. I saw someone was requesting that already. So now let me just go ahead and rewrite our problem that we have. We have natural log of x squared plus 4x plus 20 minus integral of 1 over x squared plus 4x plus 20 dx. Okay, we already have the first term. That's fine. We didn't integrate that second integral that we still need to do. So how do I cancel that out? Or I'm sorry, now how do we cancel it out? How do we integrate this? What do we prefer? Do we want to use partial fraction decomposition, or perhaps do we want to use completing the square? S is saying complete the square, and I completely agree. I hate completing the square. I think it's one of the most bogus methods out there, but it's super helpful for you to memorize it, for you to practice it, because unfortunately it just shows up. So S was correct that we are going to complete the square. So check this out. I'm going to show the work for completing the square here. We still have our first term, which is x squared plus 4x plus 20 minus 1 over x squared plus 4x. And if we complete the square, we're supposed to divide that 4 by 2 and then square it. So that's just plus 4. We have the plus 20, but because we introduced a 4, we have to make sure we subtract the 4. And so now we have everything that we had so far minus 1 over x plus 2 squared plus 16. Okay, so I completed the square. What else should we do? I can drop the absolute value. I think I could, but I'm not, it's fine. A lot of people, if I don't, or if I end up dropping it, people are going to say that I shouldn't drop it. So let's just play it safe. Anders, if you're ever doing any engineering problem and that's a path you're trying to pursue, you're going to be using integrals. Ben said arctan. That's exactly what that's going to be. So the very end, let me just make one last space on this blackboard here, and we are going to go ahead and simplify our integral. We have natural log. Actually, that's natural log of x squared plus 4x plus 20 minus 1 over 4 arctan of x plus 2 over 4 plus c. That is our integral there. Yes, I agree. If you're quick, you can definitely just solve it very easily. But sometimes it's good to show the work, because there could be some people on here that could be confused on how we completed the square. Yep, exactly. You can do this in your head, and I do it a lot of the times as well. But sometimes, we can make mistakes. But again, it's good to show that work. Okay, a simple integral that started off with just 2x plus 3 over x squared plus 4x plus 20 turned out to be this longer version of this natural log and then an arctan. Sophia, why not partial fractions? Are either one that we use, let me just erase this since we're going to start another one. If we use partial fractions, just think about it. I think that's always a good thing to start off with. But what would this factor out to? What are two numbers that multiply to 20 and positive 4? I don't really know. I don't think I can find anything because it's what, 2 and 10, 5 and 4, 1 and 20, and that's pretty much it. So you could always try it. You can technically use quadratic formula, but you're just going to end up with factors that have all these radicals and stuff. So partial fractions might not be the best method. So one thing that I would suggest is first, absolutely try partial fraction decomposition. And if that doesn't work, then go to complete the square. And if you complete the square, hopefully by then you can do a like an arctan, or if it's not an arctan, you're going to have to do something else. As a matter of fact, let's go ahead and do one. This one is for, this one's going to be for Sophia here. We're going to try partial fractions, but if it doesn't work out, we're going to try something else. Let me just kind of create it on my own here real quick. Let's go ahead and do this one. Okay, how about this one? X squared plus 4x, and then let's go ahead and do minus, it looks like that's going to be, what did I do, minus 12. Matt Fogarty, I'm always here on Tuesdays. And then Thursdays, math survival skills, and Fridays is going to be off-trail math. Okay, so let's go ahead and look at this bottom, or this integral here. Let's go ahead and start off by looking at it and think, okay, can we factor this out? Are there two numbers that multiply to negative 12 and add to 4? And it looks like there are going to be. So we have, this is going to become x plus 6 and then x minus 2. Whoops, I still have that dx there. Nice, so x plus 6, x minus 2. So let's go ahead and use partial fractions here. So this is supposed to equal to a over x plus 6 plus b over x minus 2. Right on. And then so now that we have this, we can go ahead and create or use partial fraction decomposition. We're going to have a times x minus 2 plus b times x plus 6, and this is supposed to equal to 1, which is the numerator in the integral that we had. So I'm going to go ahead and use something called the cover-up method. Some people like to, or some teachers will tell you that you have to distribute the a and the b. In this case, it might be easier to just do the cover-up method. And the way that works is we're going to go ahead and make x equal to a value so that the one of the parentheses is going to cancel out. So for example, I'm going to make x equal to 2. And look what's going to happen. I have a times, I'm plugging in the 2, minus 2 plus b times 2 plus 6 is equal to 1. This first term just going to cancel out. 2 minus 2 is 0, so we're done. And then now we just have 8b is equal to 1, so b is equal to 1/8. Ah, that's real nice. Okay, using that same idea with the cover-up method, let's go ahead and plug in x equals to negative 6 because I want that b value to cancel out. I'm going to show a little less work here. I'm not going to use, I'm not going to, put the red coloring there. But that's just going to be negative 6 minus 2 plus b times negative 6 plus 6 is equal to 1. And hopefully you can see there that the negative 6 and the 6 cancel out, so the b no longer exists. So we're left with negative 8a is equal to 1, so 8, or a is equal to negative 1/8. And now we can use the partial fractions or the sums that we had there on the top, and we can rewrite our integral as negative 1/8 over x plus 6 dx plus integral of 1/8 over x minus 2 dx. And from there, a lot of people can probably already see what this is going to become. I'm going to go ahead and create some space here. Just to make this a little neater, I'm going to go ahead and factor out the negative 1/8 from the first integral, and then I'm going to factor out the 1/8 from the second integral. And these are basic integrals that we should know. This is just going to be natural log. Yes, S is super excited. Wait, is that really your name or is it something else? Just S. I like it. Okay. He said ln. He got so excited, or they got so excited. This is going to be negative 1/8 natural log. Again, I'm just going to use the absolute value for those natural logs because you never know what that answer is going to be. And there we are, guys. Of course, worldwide, I am here every Tuesday, Wednesday, and Friday here on TikTok. And of course, if you miss or if you have to go, I always put the replays on YouTube so you could always watch them there. This is cool. I had an agenda of the types of integrals that I was doing, and then someone mentioned partial fractions, so I gave you a problem involving partial fractions. And then we had done kind of one where we had arctan. Let me go ahead and show you what happens when we don't have that. So how about this? 1 over x squared plus 4x minus 10. Differential equations, maybe not today. Again, Tuesdays are always just integrals. Perhaps on Thursdays or Fridays. I think maybe Friday because that's going to be an off-trail math where people get crazy. I love you math nerds that come in and just bring in some like crazy methods. If we do Newton's system of equations, there's going to be like 2 people watching. Anyway, go ahead and let me know in the chat, what do we suggest we should do here? Should we try to factor this out by using partial fractions decomposition? Or should we use another one? By the way, I just saw someone, can you give a problem to solve? If it's not an integral, I probably wouldn't. However, you can join my Discord. The link is in my bio. There's a bunch of math nerds that are willing to help you. Okay, so someone said factor it out. Let's try partial fractions. If we can factor it out, go ahead and tell me the factors for this. What numbers multiply to negative 10 and add to 4? This is technically calculus 1. More calculus. Actually, no, I'm going to go calculus 2 because I don't think you guys do partial fractions in calculus 1. So calc 2. Yeah, so again, no one's telling me the factors here because there isn't none. There is no factors that multiply to negative 10 and add to 4. So what are we going to do? Someone said nothing less than completing the square. As much as I hate this, we are going to have to complete the square. Trig sub, Oscar, you're trying to get wild here. Maybe. I don't know if this is a trig sub. Perhaps it is, but we'll see. Let's go ahead and complete the square. Again, let me just show all the work here. I'm dividing that 4, which is my b value, by 2, and then squaring it. So that's plus 4. And then because I introduced the 4, I'm going to subtract by 4. And then so I just want to quickly answer, can you integrate to find the speed of a vector? Can you integrate? I don't think you can. Depends on the question. I mean, it all depends on what question you have there. Let's go ahead and simplify this. I have 1 over x plus 2 squared, and then I have minus 14. So again, the first types of problems that we did was partial fractions. It worked out nicely. In this case, we had to complete the square. One of the first examples, we did arctan. This one, Pebbles, this is not an arctan, unfortunately, because look at the bottom. It is not of the form 1 over x squared plus a squared. Specifically, there is a plus in the arctan. This one has a minus. So someone said trig subs, okay? 2 people had said trig sub. Should we? I actually don't know if trig sub works, but I'm going to try it, okay? If we're going to do trig sub, let me go ahead and draw out the triangle. To be honest, I would have done this differently, but I'm going to go ahead and try out the trig sub because 2 people had said it. I think we should try it. Okay. And Oscar said, I think this is going to be a secant problem. I agree. So when you draw out your triangle, what gives it a hint that it's going to be a secant? Because on the bottom, we have the variable squared minus the constant. So that means that we're going to make this x plus 2. We're going to make this 14. And then we're going to go ahead and do the top side, or the opposite side, if you will, is going to be, no, wait a minute. I got this all wrong. What am I doing? It should be x plus 2 on top, and it should be root 14 on the bottom. If I do this wrong, I always get confused with the secant. Let me know. but I think that's going to be correct. And so now on this right side, we're going to have x plus 2 squared minus 14. Think about why I got that. Again, if you watch the replay on YouTube, make sure you pause the video and try to work this out, why these sides are what they are. And so now we can say that secant theta is equal to the hypotenuse over the adjacent, so x plus 2 over root 14, meaning that root 14 secant theta is equal to x plus 2. This is going to be helpful for us because it's going to help us find the dx. So we're going to integrate this, and this is going to be secant theta tan theta d theta is equal to dx. So that's really nice because looking at our integral, we have found the dx. And then now what we're going to do is we're going to go ahead and say that tangent of theta is equal to x plus 2 squared minus 14 all over root 14. This is just looking at the triangle that we have. Tangent is opposite over adjacent, so that's why we have that. So if I multiply the root 14 to the other side, we get tan theta is equal to x plus 4 squared minus 14. And that's going to help us write out the value for the denominator in the integral. So let's go ahead and write this out, then I'll make some space on the blackboard. So we have the integral of 1 over root 14 tan theta times the dx value. So root 14 secant theta tan theta. And then don't forget the dx. Yes, and S, could you make it what you were just saying? You absolutely can. That's actually the way I would have solved it. I would have used that partial fraction. To me, it works better, but this is working out just fine, it looks like. So both methods would have worked. So S, you were absolutely correct. Look at that comment that they mentioned, and think about what we can do there. They ended up using partial fractions instead. So let's go ahead and just simplify this. I have, if you look at the integral that we had, the root 14s cancel out, which is really nice. So we are left with the integral of secant theta tan theta over tan theta d theta. I realized that I put a dx, but it should have been a d theta. And this is nice because what cancels out? The tangents. And we're left with a nice integral of secant theta d theta. Who can tell me what secant theta is going to be, or the integral of that? Happy Pi Day, everyone. I have not been in the right mental space lately, and I totally forgot that it was Pi Day. I wanted to do like a 24-hour stream for Pi Day or something like that. But, we're just going to do a nice integral, an hour of integrals today. Hold that thought. We're going to try to solve that one that you just wrote. We'll do it in a second. So people are saying, yes, so you got to memorize this integral because there's no way that we want to work it out. There's a whole proof, and there's many proofs for this one, but memorize the integral of ln or secant theta. And that's going to be ln of secant theta plus tan theta. All right. And I'm claiming we're done. Are we complete? Is this integral over with? Can we erase it, or is there something else that we have to do? Yep, someone said change it to x, and that's exactly what we need to do because technically this is secant. It's in terms of theta, so we need to go back to our triangle, and if you recall, I'll highlight it. Secant theta was up here. I'm going to highlight that in red, and then tan theta was this value, the one that I highlighted in red again. So now we have natural log. Whoops, let's go ahead and use actual marker. Natural log was x plus 2 over root 14 plus x plus 2 squared minus 14 over root 14 plus c. And had you done partial fractions, then I believe you would have gotten that same answer. This is actually a lot neater than I thought. I was going to get crazy and do partial fraction decomposition instead of trig sub, but this worked out just fine. Okay. Someone posted in the comments here if we could do a specific integral. I don't even know how to solve that I could think of, but let's try it out. Okay, I'm going to write it out, and if it's written incorrectly, let me know. I have integral of 1 over 25 e to the negative 9x plus e to the 9x dx. Okay, that's the way it was written. And I'm hoping that's the right one. Okay, cool. Well, let's go ahead and start off by, I see the 25. Let's go ahead and do some u sub, just to get rid of that negative 9x, okay? This might not be the only sub that we have to do, but for now, let's just make u equal to negative 9x. du is equal to negative 9 dx. So then du over negative 9 is equal to dx. And then so now what we have is integral of 1 over 25 e to the u plus e to the u. I'm sorry. Oh, I should have just made it positive 9x, but okay. I'm just going to do e to the u plus e to the negative u. I had to change that second one because technically the second e had a positive 9x and it still needs to be positive. So let's go ahead and do negative u there. Okay, and then now we have our du, so our du over negative 9. So a couple things that I'm going to do here is I'm going to go ahead and move the negative 9 on the outside so that I have negative 1 over 9 integral of 1 over 25 e to the u plus, and then just to rewrite this, I'm going to do 1 over e to the u. Yep. So some people are saying to multiply. So it's going to be the same thing. Okay. You could do that, and I'm basically doing it right now. So you could have done that in the very beginning. I think that's fine. So what they're saying is in the very beginning, they wanted to rewrite that e to the negative 9x and then just kind of simplify it. But I'm doing it here in this step, which is probably going to require me to do another u sub. So now what we're going to do is we're going to multiply both the top and the bottom by e to the u. And that what that does is now we have negative 1 over 9 integral of e to the u over 25 e to the 2u plus 1. Oh, okay. I think this is going to be a lot easier. I don't think this should be too bad. At least I don't think so. Some people just have problems with specific integrals, or sometimes they're so busy or like they're so stuck on it that they can't see, a simple thing that they should have tweaked. It happens. It happens to all of us. But this is why we're doing it, because there could be someone out there, another math nerd, that was doing a problem like this and it clicked for them. Okay, we'll talk about that problem. I just saw it. Okay. We'll try to do that one after Arturo, sorry. All right, so looking at the bottom, it looks like we have 25 e to the 2u. I can already tell, just because 25 is a perfect square and then the e to the 2u, that we can probably rewrite this as 5e to the u squared plus 1. And then, as I mentioned, we were going to have to do another u sub. I'm going to do w equals 5e to the u, and then dw is equal to 5e to the u du. So dw over 5e to the u is equal to du. You're going to see that this is going to be helpful. I'm going to go ahead and make this smaller. And now what we have is negative 1/9 integral of e to the u over w squared plus 1 times dw over 5e to the u. I don't know why I did so many u's here, but you could have done this in a lot less steps, and you're going to see why I'm saying that. The e to the u's cancel out. The 5 could be brought out here. So now we have this integral, negative 1 over 45, integral of 1 over w squared plus 1 dw. And this is just a classic arctan. Yes. Can you simplify this in the very beginning to avoid so many subs? Absolutely. I don't know what I was thinking. I think I was trying to read the comments at the same time, but whatever. Guys, I'm not very smart. I just do these problems for fun sometimes. So, like I mentioned, that integral is a simple arctan. So we have negative 1 over 45 arctan of w plus c. And if you recall, again, to avoid so many subs, you could have done this in the very beginning. I think you could have made your u equal to e to the negative 9x or something like that. But if you recall, w was equal to 5e to the u. So we have negative 145 arctan of 5e to the u plus c. but then u was equal to negative 9x. So now we have negative 145 arctan of 5e to the negative 9x plus c. Yeah, you can simplify this in so many different ways. To be honest, I did multiple subs. Probably should have made it a little easier. Okay, let's do, someone else brought up, you're welcome. If someone else brought up another integral, and then Oscar, we'll try to work on yours after, but that one is actually really interesting. We'll try it out after. But anyway, let's go ahead and erase this. Let's look at the comments. Hold on. Someone had mentioned, okay, Arturo had requested secant to the 4 power, or secant 4 3x times tan cubed of 3x. Okay, dx. Any thoughts, guys? I feel like I kind of see what we can do. Oh, I see it already. Okay, but let's see what people are saying in the comments. So, Arturo, you're probably learning the power reducing formulas here, and that's exactly what you're going to do. And it's definitely going to be a U sub type problem. The only thing that I want to do before I even do that, someone said you can do this with one step, and I kind of agree. But I'm just going to show you again. There's so many different ways of solving this, but I'm going to show you the way I would have solved it. I already know I'm looking at, I want to make u equal to tan. That's what I want to make my u. But I know when I take the derivative of that, I'm going to get secant squared. And that's only going to cancel out half of these. So what I'm going to do, before I even do anything, is I'm going to go ahead and rewrite this as secant squared 3x times secant squared 3x. You're going to see why I'm doing this in a second. And someone says split the tan into secant. I'm going to do the other way around. I'm going to split the secant into tan. Because if you recall, there is a formula. It's 1 plus secant, whoops, not this one. 1 plus tan squared is equal to secant squared. And that's what I'm going to plug in for this secant squared. And that's going to give me secant squared 3x times 1 plus tan squared x, or this is 3x, I'm sorry, times tan 3 of 3x dx. Okay, you can go ahead and distribute the tan if you want to. But what I'm going to do, yeah, let's just do that now. I'm going to go ahead and distribute this tangent into both of these so that I get secant squared of 3x, and this becomes tan cubed of 3x plus tan to the 5th of 3x dx. And then now you can go ahead and make your u equal to tan of 3x, and your du is going to be secant squared 3x times 3 dx. And I'm going to divide all those values to the other side, so I have du over secant squared 3x, I'll just put the 3 on the outside, dx. Let's go ahead and make this a little smaller. And then someone, again, had requested another integral, which we'll do together. And so now we have secant squared of 3x, parentheses, u cubed plus u to the 5th times du over 3 secant squared 3x. And that's great because that's exactly what we wanted. So those secant squares are going to cancel out. That 3 that's on the bottom is going to move to the outside, so we have 1/3 integral of u cubed plus u to the 5th du. And then now we just integrate using power rule. So this is 1/3 u to the 4th over 4 plus u to the 6th over 6th plus c. So I'm going to do two things in one step. I'm going to first make this a little smaller. That's not one of my steps. But I'm going to go ahead and distribute the 1/3 to both terms. And at the same time, I'm going to go ahead and plug in my value of tangent back in for my u. So that's 1/12 tan to the 4th of 3x plus 1/18 tan to the 6th of 3x plus c. All right. Arturo, you just got to mess around with it. Honestly, one of the things is just kind of being aware. It's like saying, okay, what we already know that you're giving me an integral, and you have secants and you have tangents. I know they're related in a way that tangent or the derivative of tangent is secant squared. So try to find that secant squared somewhere in there and just, break it down one at a time. Okay, someone else had said, Evan, nice job. Congrats with that 92. Let's go. Shout out. Okay, someone had mentioned, and I'm just going to make sure I wrote it right. Okay, so Oscar had said, can we take the integral of 1 plus x cubed dx? Oh, and Arturo, I'm sorry if I erased that too soon, but you can always check hopefully you took a screenshot, but also I do a pre-recording that, or a recording that I put on YouTube. Hey, good luck on that final. You got this. Okay, so Oscar, this was the problem that you brought up, 1 plus x cubed, or the root of 1 plus x cubed. I'm like stuttering today. This integral of square root of 1 plus x cubed. All right, chat, any ideas? And by the way, you guys can always post this on my Discord where you guys can ask a bunch of math questions because there's people out there that are more than willing to help. Trig sub with tan. Okay, I'm going to run with that. I actually don't know the first thing that we can do here. Trig sub with tan. Well, so that will make, let's try it. Why not, right? If we do tan, then that means that this is square root of x cubed. And then this is 1, and then this is 1 plus x cubed. So that's the only way. Again, if you guys are confused on how we set this triangle up, we just have to make sure that this fits or this satisfies the Pythagorean theorem. So let's see if this works. I mean, I hope so. Gosh, I don't know. We're going to try it out. So tan of theta is equal to root x cubed. But then here's what the issue is. If we take the derivative of this, it should be secant squared theta d theta, you run into this like 3x squared over 2 root x cubed dx. That doesn't cancel anything out. So that would be yeah. This is a little tricky because then if we try to rewrite this, then we have the square root. I'm not going to lie to you. I'm seriously just going to look at some steps that people did here online. I think I'm stumped because it doesn't seem to work on here. Again, anyone else that sees this, oh my goodness, I saw the answer to this, and it is insane. Did you get this for your homework, Oscar? Wowza. Okay, so I'm just going to show you what the answer looks like. I literally just went on Symbol Lab. Check this out. I'm going to put it on here. If you can see what the answer is, this is just part of it. This is what they're telling you. The answer is it's this entire value on the bottom. And they're even telling you that it's a non-elementary integral. Wow. So to be honest, I have no clue right now. I am stumped. Good for you. I love that you love steak. That's your thing, man. I'll judge you, but that's your thing. So Oscar, it's practice. Interesting. Okay. Yeah, I would definitely I'll look into that one. I got to say, for this live, I'm a little stuck on it. Okay, so maybe we can move forward, and I apologize that I failed you on this one. Oh, the root of tan x. We are, you know what? I'm gonna save that one for a TikTok video just because it's like, well, I guess we can just do it now, right? If you want. Do you guys want to do the integral of arctan? Yo, I really wanted to do the integral of arctan. Oh, Arturo, right away, just looking at that one, because there's an X in the front, I believe that's going to be a secant one. Yep, integrals are crazy. I completely agree. Okay, so integral of arctan. I do remember this one. This is one of the ones where I just kind of like memorize it, but it's just a little tricky on the way we have to, or in the way they want you to do it. Some people like to use what is it called? The Weierstrass method. Okay, so again, I memorized this one. I remember what the. It's going to be a little confusing, but here's the way it works. Let me just kind of show you this one, and then Arturo, I'm going to try that other one that you did, and then that'll be the last for today. Okay, guys. So let's go ahead and just kind of start off like this. We have u over, or u is equal to root tan of x. Okay, so I'm going to go ahead and square both sides and just say that u squared is equal to tan x. And then now I have my 2u du is equal to secant squared x dx. And now I'm going to divide the secant squared to the other side. So we have du over, or 2u du over secant squared x is equal to dx. But don't forget, one of the things that that we can do on the bottom here, secant squared x is an identity. We can rewrite the secant x before we start writing anything and put tan squared x, or not tan squared x, 1 plus tan squared x. That is one of the Pythagorean identities. Okay? So just keep that in mind. And then so now what we have is we have the integral of u times, because our u was the root of tan, and we have 2u du over 1 plus tan squared x dx. Now, a few things that I'm going to do. I'm going to multiply the u to that 2u to get 2u squared du over, and I'm going to rewrite the bottom as 1 plus u squared. Why? Because the tan is a u. Okay, because remember, I'm sorry, I don't know why I did u squared. If you recall that u squared is equal to tan x, so if I do u to the fourth, that's tan squared x. So on the bottom, instead of u squared, I'm going to do u to the fourth. So this is what we're left with. Let me go ahead and make some space on the blackboard. Whoops, didn't mean to do that. Let me go ahead and make some space here on the blackboard. We're going to simplify this. I guess I didn't want to make it that small. Let's go ahead and do this. And I forgot who was asking me this, but once you have this, what you can do is, I'm still going to leave the 2 on there. Du over 1 plus u to the fourth du. Oops, I still have the 2 d to the fourth. There we go. So now we have this integral here. Okay, 2u squared over 1 plus u to the fourth. Yes, thank you. Samuel, u to the fourth. Yep, u to the fourth. Hopefully, I think that was previous chats on there, but hopefully you guys saw that I fixed that. I know, I can't believe I did u squared there. Okay, so u to the fourth. And then so now it's our job to try to simplify this. So you either have to do some partial fractions, you have to go ahead and simplify this in different ways. And here's the way some people do it, okay? And again, I remember memorizing this. It's not one that you would always have on a test, but you're going to go ahead and rewrite the top as 2u squared, and you're going to put a plus 1, or you're going to add a plus 1, and then subtract the 1 at the same time. So you have 1 plus u squared du. Okay? And so now what you have is you have u squared plus 1 plus u squared minus 1 all over 1 plus u to the 4th. I realize that I put u squared, 1 plus u squared, but it's 1 plus u to the 4th in that other integral. Okay, so look at what I did. I added the 1, subtracted the 1, because it still balances out the equation. And then I cut up the 2u squared as a u squared plus u squared, and then I rewrote that as 2 different factors. So what I'm going to end up doing is I'm going to have 2 different integrals that look like this. Okay? So that's the way I want to integrate them. So now I have integral of u squared plus 1 over 1 plus u to the 4th plus integral of u squared minus 1 over 1 plus u to the 4th, and the whole thing is du. And I want to say that's more helpful, but I'm not sure if it is. Yeah, so just think about that, okay? I have to hop off in a few minutes, so I definitely want to touch on another question that I believe someone else had that I'm going to try to do. Yeah, so you might have a problem with 1 u to the 4th. Oh, I want to say, so for this one, can you do partial fractions? Because technically, no, you can't factor this out. Okay. For this one, let's see. Any other suggestions on how we can simplify this, or how we can integrate this 1 plus u to the 4th? Can you do partial fractions there? Yeah. I know, u to the 4th, just, I don't like it. I don't like u to the 4th. Does it? Sum of u to the 4th has a factorization? I mean, I guess what you can do, wait, okay, let's try this. Oh, yeah, I see what you mean. I could have sworn that I fixed it the first time, and I didn't. Okay, so they're referring, let me just rewrite this. By the way, this u squared is not u squared, it should be u to the 4th, so I'm just going to go ahead and erase that. So what if I do, oh my gosh, I was going to factor it, but I can't even factor it as a factorial. Yeah. I don't know. So this is kind of where we have to start simplifying it. Maybe that's something that I'm going to do. I'm actually going to take a screenshot of this because I want to redo this one. So there were 2 problems that I wanted to do, and I said I was going to leave them for some TikTok videos. But again, leave you guys with the final integral that you guys should maybe practice. I'm going to practice it myself. But I do have to get going, unfortunately, and it sucks that we're leaving on this note. But this is good, because if you're seeing a replay on this and if you see it on YouTube, comment below what your next steps are going to be or what you would suggest you do. Before, let me just read this last comment. Transform the 1 as 1 over u to the 4th 1. Can you do that? Transform the 1. Okay. Transform the u squared as 1 over u to the 4th over 1 over u to the 4th. Ooh, okay. Let me just leave this as a little note. I'll put it in green, and then I'll sign off. Someone said, rewrite the 1 as, so this will be u squared plus 1 over u squared over 1 over u squared. I think that's what you said to do. But then I'm curious what that even is going to do to our problem. Because then you're going to have like u to the 4th. You're going to have some issues there. But anyway, I'm going to leave that there for some people to think about. But that's what someone in the comments said. Okay, and it shouldn't be a dx. It should be d to the u. Awesome. It will be easier to cancel. I am going to try that out. Yeah, but then see, Samuel, if you do w Anyway, I mean, we're gonna get caught up in this, and I love that we're talking about this type of problem. But I do have to sign out, unfortunately. I'm gonna try to create a video on this that I'll post on TikTok or one of my Instagrams. That way you guys can look at it. But anyway, hopefully you can kind of see the steps to derive this or to integrate this, and then at the end, that's where you're left with another tough integral to solve. Randy, the most beautiful equation is e to the I pi plus 1 is equal to 0. Happy Pi Day, everyone. I hope everyone is having a good Monday. I'm going to see you guys on Thursday where we do some math survival skills. We'll see what it is. I know the AP exam is coming up, so I think we're going to do a lot of AP review for those AP students. So every Thursday, I'm going to try to hop on and do some AP review for that. And then Friday, we can do some someone was talking about it, whether they wanted like optimization problems or they wanted to do some other crazy integrals. We can talk about that on Friday. All right, guys. Anyway, hope you guys have a great rest of your day. I'm going to see you all on Thursday around the same time, or if not, catch the replays on YouTube. Don't forget to follow me here on TikTok, follow me on Instagram, follow me on YouTube, and I'm going to see you guys real soon. Take it easy. Bye now.